In this video, I will explain the vocabulary for Chapter 1. Matter. Matter is anything that has mass and takes up space. Here in the pictures we see people, cell phone, trees, grass, football. All of these things are matter. Chemistry is the study of matter and how matter changes. So as we study chemistry, we will be focusing on matter, what it is, and how it changes. Substance. A substance is a single kind of matter that is pure. That means it's only made up of one thing, one element or one molecule. Here we see some gold bars. They're only made up of gold, so it's pure substance, pure gold, just gold throughout. Salt is another substance. It's only made up of sodium chloride. Water is another substance. It's only made up of H2O molecules. An example of something that is not a substance would be salt water, because salt water is a mixture of two different substances. Milk, blood, apple juice are also examples of things that are not substances. Properties describe matter. A physical property is a characteristic of a substance that we can observe without changing it into another substance. Things like color, size, shape, texture, melting point, whether or not it can dissolve in water, those are all things of physical properties. We can observe these without it changing into a new substance. Chemical properties, on the other hand, describe how substances can change into different substances. A chemical property is a characteristic of a substance that describes its ability to change into different substances. Here we see a rusty train. The metal of the train has reacted with oxygen in the air over time to form a new substance, rust. We also see a match. Matches are flammable. Flammability is another chemical property. Element. An element is a substance that cannot be broken down into any other substances by chemical or physical means. So these are the basic types of atoms. We have gold, carbon, nitrogen, phosphorus, silver, hydrogen, magnesium, sodium, helium, neon, potassium. These are all examples of elements, and they can be found in the periodic table. They're the simplest form of matter. Atom, the basic particle from which all elements are made. The atom is the smallest unit of an element, and it consists of protons, neutrons, and electrons. Atoms can attach to one another, and we call that a chemical bond. A chemical bond is a force of attraction between two atoms. Here we see some red and white and blue and black atoms, and we have some gray attachments. Those are representing chemical bonds. A molecule is a group of two or more atoms held together by chemical bonds. Here we have a water molecule. One oxygen atom is attached to two hydrogen atoms with chemical bonds. A compound is what we call a substance that is made of two or more elements that are chemically combined in a set ratio. For example, sugar is a chemical compound made of hydrogen, oxygen, and carbon. Water is a chemical compound made of hydrogen and oxygen. Carbon dioxide is another chemical compound made of carbon and oxygen. A chemical formula shows us what and how many elements are in a compound. Water has the chemical formula H2O. That means that there are two hydrogen atoms and one oxygen atom in a molecule of water. If something isn't a substance, it is a mixture. A mixture is two or more substances that are together in the same place, but their atoms are not chemically bonded. For example, lemonade, soda, and sand. There are different substances that are mixed together in the same place, but they don't undergo a chemical reaction and their atoms do not bond together. Soda is a mixture of water, carbon dioxide in the form of carbonation, sugar, flavors, and salt, and some other things that are all together, mixed together, but they don't undergo a chemical reaction and bond together. Something important about mixtures is that they can be separated. The substance can be separated, sometimes easily, sometimes a little more difficult, but they can be separated. Weight is a measure of the force of gravity acting on an object. Weight is measured using a scale. Mass is different than weight because mass is the amount of matter in an object. It doesn't have anything to do with forces acting on the object, just the amount of matter in an object. The squishy and the slime each have their own mass because of how much matter is in them. The International System of Units, abbreviated SI, is the system in science that we use for units of measurement. It is a system of measurement based on multiples of 10 and on established measures of mass, length, and time. Most of these are based on the metric system. We use meters, kilograms, liters. Volume is the amount of space that matter occupies. This squishy occupies a certain amount of space, and that is its volume. Density is a measure of the mass of a material in a given volume. You can see that we have the same volume in these two squares, A and B. They both have the same volume. They both take up the same space. You can see in square A, there is much more matter inside the square than there is in square B. So we can say that square A has a higher density than square B. Matter can change. That's one of the things we study in chemistry. A physical change is a change that alters the form or appearance of matter, but does not turn the matter into another substance. Here we see paper being cut. We can cut the paper. We've changed it, but it's still paper. There's a popsicle melting here. It is changing from a solid to a liquid, but it's still made up of the same chemical compounds. Nothing has changed there. And here we're dissolving some salt in water. Again, the salt is still there, the water is there. They haven't chemically combined. We could separate them out. We've made a mixture here. So this is a physical change. A chemical change. A change in which one or more substances combine or break apart to form new substances. When something gets burned, it undergoes a chemical change. It is no longer the same substance. When this match is burning, it's giving off carbon dioxide and water, as well as leaving behind the charred remains. So the charred remains are different than they were before. You can see how the color has changed, the consistency has changed. It's much more fragile now. We can't see it, but water and carbon dioxide have gone away from the reaction. Baking soda and vinegar mixing together, we can see bubbles forming here. That gives us evidence that a gas has been produced, a new substance. Glow sticks are an example of a chemical change. When you crack open that glow stick, two substances mix together. And when this process happens and chemical change is being undergone, light is given off in this reaction. Cooking food is also an example of a chemical change. Chemical changes are very hard to reverse. That is one of the things that can kind of give you a hint if it's a chemical change. The law of conservation of mass says that the total amount of matter is neither created nor destroyed during any chemical or physical change. So that means the number of atoms going into the reaction has to be the same as the number of atoms coming out of the reaction. We don't destroy matter, we don't create new matter, we just rearrange it into new ways. Temperature is a measure of the average energy of motion of the particles of a substance. The higher the temperature, the more energy the molecules have and the faster they move. The lower the temperature, the less energy the molecules have and the less they move. Thermal energy is the total energy of all the motion of all the particles of an object. So the more the particles are moving, the higher its thermal energy. An endothermic change is a change in which energy is absorbed, meaning taken in. Melting would be an example of an endothermic reaction. Energy goes into the ice cube, increases the temperature, and it melts. An exothermic change is a change in which energy is released or given off. In a glow stick reaction, energy is given off in the form of light. Chemical energy is a form of energy that is stored in chemical bonds between atoms. And food is an example of chemical energy. We get energy from our food because our body breaks down that food. It breaks those chemical bonds and releases that energy. Wood has chemical energy stored in it. When we burn wood, we release that energy. Batteries are also examples of chemical energy.